The ocean looks shallow because we meet it at the top. We see waves, foam, beaches, harbors, ships, sunlight, and the changing color of weather. The surface gives the impression of a boundary, as if the sea were a blue sheet spread across the planet. From shore, the ocean appears horizontal. Its true dimension is vertical. The average depth of the ocean is about 3,682 meters, more than 12,000 feet. That average already places most of the ocean far below the reach of ordinary human experience. The deepest known point, Challenger Deep in the Mariana Trench, is about 10,935 meters below the surface. These numbers are easy to read and difficult to feel. They describe a world where mountains can disappear beneath water. The ocean is deeper than you think because human senses were built for land. We understand hills, buildings, roads, trees, cliffs, and clouds. Depth underwater removes familiar reference points. A kilometer downward in the ocean is not a visible distance. It is a transformation of pressure, light, temperature, sound, and life. The surface is only the beginning. The first 100 meters can feel like the ocean itself because it is the part humans can most easily imagine. Divers enter it. Sunlight fills it. Fish move through it with visible color. Reefs, kelp forests, seagrass beds, and coastal ecosystems occupy this upper realm. Waves above and life below seem connected by light. Yet even here, the body begins to meet limits. Pressure increases quickly. At 10 meters, the pressure is already roughly twice what it is at the surface. At 30 meters, diving becomes more technical, and risk management becomes more serious. Breathing gases, decompression, nitrogen absorption, visibility, currents, and temperature all matter. The ocean becomes dangerous long before it becomes truly deep. This is why surface familiarity can mislead. A swimmer may look down through clear tropical water and feel that the sea is open and simple. A diver knows that every meter changes the rules. The first 100 meters are only the bright entrance hall of a building that descends for kilometers. Below roughly 200 meters, sunlight weakens until photosynthesis can no longer support the world directly. This is the twilight zone, or mesopelagic zone. It extends down to around 1,000 meters. Light remains present in faint traces near the top, enough for animals to hide, hunt, and migrate according to the dim rhythm above them. The twilight zone is one of the least familiar large habitats on Earth. Each day, huge numbers of animals migrate upward at night and downward before daylight returns. Small fish, squid, crustaceans, and gelatinous organisms move through the water column in a vast vertical pulse. This migration helps transfer carbon from the surface to deeper waters and connects the bright ocean with the dark one. For humans, this zone already lies beyond normal access. It is too deep for ordinary diving, too dark for casual observation, and too large for simple sampling. It is the beginning of the ocean as a hidden volume rather than a surface. A person floating above it sees only water. Beneath that water, an entire migrating world rises and falls every day. At 1,000 meters, the ocean enters permanent night. Sunlight has vanished. The pressure is about 100 times greater than at the surface. The water is cold. Human presence requires submersibles, remotely operated vehicles, pressure-resistant instruments, or specialized sampling gear. A descent to this depth is already a journey into a world that rejects the human body. Life continues there, but it has changed. Many animals produce light through bioluminescence. Predators use lures, enormous mouths, sensitive eyes, or patient ambush. Prey use transparency, darkness, counter-illumination, speed, or drifting forms. Food is scarcer than near the surface, so energy conservation becomes a governing principle. The deep ocean is not empty. It is disciplined by scarcity. 1,000 meters is deeper than many mountains are tall, yet it is still far from the bottom in much of the ocean. This is one of the hardest truths to absorb. Reaching the midnight zone can feel like reaching the abyss, but the descent may have several kilometers left. The ocean's depth is not one threshold. It is a sequence of thresholds. Below roughly 4,000 meters, the abyssal zone begins across much of the ocean. This is the realm of abyssal plains, deep sediments, seamount slopes, cold water, and slow life. The pressure is enormous. The darkness is absolute. Food arrives mainly from above as marine snow, dead plankton, fecal pellets, mucus, shells, dust, and other organic material falling through the water column. The abyss is the largest seafloor environment on Earth. It can look quiet in camera footage: mud, pale animals, occasional tracks, slow-moving sea cucumbers, brittle stars, worms, crustaceans, sponges, and fish. Yet quiet does not mean lifeless. Microbes transform sediment chemistry. Animals feed, burrow, scavenge, and reproduce. Carbon is buried. Records of past climates accumulate layer by layer. The depth changes time itself in the imagination. At the surface, storms move fast. Tides rise and fall. Waves break and vanish. In the abyss, many processes unfold slowly. Nodules can form over extremely long timescales. Corals may grow slowly. Disturbance can persist. The ocean is deeper than we think because it contains these slower clocks beneath the rapid world of weather. Depth does not mean flatness. The ocean floor holds mountains, ridges, plateaus, volcanoes, trenches, and canyons. The mid-ocean ridge system forms the longest mountain chain on Earth, winding through ocean basins for tens of thousands of kilometers. Seamounts rise from deep water like islands that never reach the air. Some are taller than famous mountains on land, yet their summits remain hidden below the surface. This hidden relief makes the ocean difficult to imagine. A ship may pass over an underwater mountain without any visible sign. A current may be deflected by terrain no passenger can see. Deep-sea corals and sponges may live on slopes that exist only as sonar shapes and rare camera footage. The surface conceals not only depth, but landscape. If the water were removed, the planet would look startling. Continents would be bordered by shelves, slopes, trenches, ridges, and abyssal plains. The ocean basins would appear as enormous provinces of rock and sediment. The deepest places would look like wounds in the crust. The familiar blue planet would become a rugged world of hidden geography. The hadal zone begins below about 6,000 meters, mainly in ocean trenches. These are the deepest habitats on Earth, formed where tectonic plates bend and sink into the mantle. The Mariana Trench contains Challenger Deep, the deepest known point of the ocean. Other trenches, such as the Tonga and Kermadec trenches, also reach extraordinary depths. In the hadal world, pressure dominates everything. At Challenger Deep, the pressure is roughly 1,000 times greater than at sea level. Machines must be built with extreme care to survive. Ordinary structures would implode. Human bodies cannot function there without protection. Even scientific instruments must be designed around pressure, corrosion, darkness, and recovery. Life still exists. Amphipods, microbes, sea cucumbers, worms, and specialized fish in certain trenches have been documented in hadal environments. Food can collect in trench basins as material slides down slopes or sinks from above. The deepest ocean is severe, but it is not sterile. It is one of Earth's outer frontiers for animal life and microbial survival. One reason ocean depth is hard to imagine is that vertical distance underwater is also pressure distance. On land, climbing a mountain changes temperature, oxygen, and weather, but it does not crush the body with increasing force. In the ocean, every 10 meters adds roughly another atmosphere of pressure. Depth becomes a physical burden. This pressure changes exploration. A vehicle descending into the deep must maintain a protected interior while the water outside presses inward. Windows, seals, cables, batteries, floats, thrusters, and housings all become potential failure points. A small flaw can become catastrophic. The deeper the vehicle goes, the narrower the engineering margin becomes. Pressure also shapes life. Deep-sea organisms are chemically and structurally adapted to their environments. Many cannot be brought to the surface intact. Their bodies, proteins, membranes, and buoyancy systems depend on conditions that humans experience as hostile. The ocean's depth is therefore biological as well as physical. It creates worlds where life itself must be built differently. We can look up into space with telescopes because light travels across vacuum. The ocean blocks vision quickly. Sunlight fades with depth. Suspended particles scatter light. Water absorbs colors. Radio waves do not travel well through seawater. Sound travels farther, so sonar becomes essential, but sonar gives shapes, distances, and echoes rather than the direct visual richness of daylight. This is why the ocean can remain unknown while being close. A satellite can photograph continents in detail, but it cannot simply see through kilometers of seawater to the bottom. Mapping the seafloor in high resolution requires ships to cross the surface slowly with sonar. Visual exploration requires cameras and vehicles to enter the water column and descend. The difficulty of seeing downward creates a strange imbalance. Humanity has detailed images of Mars, the Moon, and distant galaxies, yet much of the ocean floor remains mapped only in broad terms. The deep ocean is not hidden because it is far away. It is hidden because water is an effective veil. The average ocean depth, about 3,682 meters, can sound less dramatic than Challenger Deep. Yet this average is itself extreme. Most humans will never descend even 1 kilometer into the sea. Commercial aircraft fly at altitudes that people discuss casually, but equivalent ocean depths feel abstract because they cannot be seen from outside. At average ocean depth, pressure is hundreds of times greater than at the surface. Light is absent. Temperatures are cold. The seafloor may be mud, rock, slope, canyon, ridge, or plain. The creatures there live in a world where food is scarce and the surface is a remote source of falling particles. This is the ordinary depth of the planet's largest environment. The ocean is deeper than you think because even its average is beyond ordinary imagination. The deepest point is spectacular, but the average depth is the real revelation. Most of the ocean is already deep enough to be alien to the body, the eye, and the instincts of land animals. Sound behaves differently in the ocean than light. It can travel long distances, bending through layers of temperature, pressure, and salinity. Whales use sound to communicate across vast spaces. Humans use sonar to map the seafloor, detect objects, navigate, and study marine life. Depth creates acoustic channels where sound can travel efficiently over great distances. This acoustic world adds another layer to ocean depth. The deep sea is dark, but it is not silent. It contains whale calls, cracking ice, earthquakes, landslides, ship noise, rain, biological sounds, and the low movements of Earth itself. Some sounds travel farther than their sources could ever be seen. For animals, sound is a way of making distance navigable. For humans, it is a tool and a disturbance. Sonar can reveal hidden terrain, but human noise can also affect marine life. The deeper ocean is therefore a soundscape as well as a landscape, one that human ears rarely hear directly. Every animal in the deep ocean lives beneath a column of water. That column shapes its body, behavior, and limits. A deep-sea fish does not think of pressure as danger because it evolved inside that pressure. A surface fish brought downward would fail. A deep fish brought upward may also fail. Each belongs to its layer. This layered belonging is one of the most beautiful aspects of ocean depth. Life is distributed according to pressure, food, oxygen, temperature, light, and habitat. Some animals migrate vertically each day, crossing hundreds of meters. Others remain close to the seafloor. Some live near vents. Some drift in the water column. Some survive in trenches where pressure reaches levels that seem impossible from shore. The ocean's depth creates ecological worlds stacked above one another. A whale at the surface, a lanternfish in the twilight zone, a squid in the midnight zone, a sea cucumber on the abyssal plain, and an amphipod in a trench are all part of the same ocean, yet they inhabit very different realities. Human exploration of the deep ocean has always required humility. Free diving, scuba diving, saturation diving, submarines, remotely operated vehicles, and autonomous systems each extend access. but each also reveals the limits of the body. The deeper the ocean becomes, the more exploration depends on machines. Only a small number of people have visited the deepest parts of the sea. More people have experienced spaceflight than have personally reached some extreme ocean depths. The comparison is striking because the ocean is here, on Earth, connected to every coastline. Yet it remains one of the hardest environments to enter. The deep ocean resists casual presence. It demands engineering, planning, weather windows, recovery systems, funding, and risk. A single dive can take years of preparation and cover only a tiny area. This is why the ocean can be familiar at the surface and mysterious below. Access narrows with every meter. Depth changes the way we think about the planet. A map of the world usually shows coastlines and land borders. It flattens the sea into blue space. Bathymetry restores the hidden dimension. It reveals continental shelves, slopes, trenches, ridges, fracture zones, and abyssal basins. It turns the ocean from background into terrain. When the ocean is understood vertically, Earth becomes more dramatic. The distance from the surface to Challenger Deep is greater than the cruising altitude of many aircraft. The abyssal plains sit under kilometers of water. Trenches cut downward into the crust. Seamounts rise in darkness. Entire ecosystems exist beyond sunlight. The planet's largest habitat is also its least visible. This depth should change our sense of scale. The ocean is not a thin film around the continents. It is a vast body of water with internal weather, layers, migrations, sounds, currents, and landscapes. It is deeper than the eye suggests and more complex than the surface can show. Depth changes not only pressure and light, but the feeling of time itself. Near the surface, the ocean seems restless. Waves break in seconds, foam forms and disappears. Wind patterns shift by the hour. Tides arrive and retreat in a visible rhythm. The upper sea belongs to motion that humans can watch directly. In the deep ocean, time stretches, growth slows, disturbance lingers. Recovery may take decades, centuries, or longer. A coral reef in shallow tropical water can feel fast with color, feeding, spawning, and competition. A deep-sea coral garden may grow with almost glacial patience, building structure over spans of time that exceed a human career. Polymetallic nodules on abyssal plains can take immense periods to form. Sediments settle grain by grain, preserving changes in climate and ocean chemistry layer after layer. A scar on the seafloor may remain visible long after storms above it have been forgotten. This altered tempo is one reason the deep ocean is difficult to respect properly. Human industry moves quickly. Scientific funding cycles move quickly. Political attention moves quickly. The abyss does not. It records, buries, grows, and recovers on scales that do not match ordinary human impatience. The ocean is deeper than you think because it is not only far below, it also belongs to a slower order of time. The deeper the ocean becomes, the harsher the meaning of distance. On land, help can move across roads and skies. In the upper ocean, rescue vessels, helicopters, and divers may still have some chance of response. In the deep sea, rescue becomes less a question of bravery than one of engineering and circumstance. Pressure, darkness, and remoteness narrow the window in which intervention is even possible. A vehicle lost in deep water cannot simply be approached by another craft the way one ship might aid another at the surface. It may lie on a slope, in sediment, or in rugged terrain. Currents may complicate positioning. Communication may be limited or absent. Even locating the object can take time, and time is the one resource least available when human life depends on air, power, and structural integrity. This is one of the least intuitive truths about ocean depth. At the surface, the sea feels open. A person in trouble can wave, call, signal, drift, or be seen. At great depth, visibility vanishes, sound behaves differently, and the body cannot survive unprotected for an instant. The ocean becomes not just a place of danger, but a place where rescue itself may arrive too late or not at all. Depth is a kind of isolation that cannot be negotiated with courage alone. People often imagine the deep ocean as still water pressed into silence. In reality, motion continues far below the surface. There are boundary currents, deep overflows, thermohaline circulation, eddies, bottom flows, and internal waves moving through layers that sunlight never reaches. Some of these motions are slow compared with surface storms, but slow does not mean weak. Over enough time, deep currents shape sediments, distribute oxygen, move heat, and influence where life can thrive. Internal waves are among the most astonishing examples. They move within the ocean rather than on its surface, traveling along boundaries between water masses of different density. Some can be immense, with amplitudes far greater than visible waves above. They may break against slopes, stir nutrients, and affect mixing in ways the eye on the surface would never suspect. The ocean contains hidden weather inside itself. The deep circulation of the sea also connects basins, climates, and centuries. Water sinking in one region may not return to the surface for a very long time. Oxygen carried into depth can sustain life. Heat stored below can shape climate in delayed ways. Carbon absorbed at the surface may be transported downward and remain out of contact with the atmosphere for long periods. The ocean is deeper than you think because its motion is not confined to waves and tides. It has an interior circulation as complex as any atmosphere. Depth also has a psychological dimension. Humans evolved to orient themselves by horizon, gravity, daylight, landmarks, and breathable air. The deep sea strips away nearly all of these references. There is no natural light, no up and down in the familiar visual sense beyond instruments and gravity inside a vessel. No distant landmark, no open sky, and no ordinary soundscape. The result is an environment that can feel less like travel and more like departure from the human condition. This is why deep ocean footage often feels unsettling even when nothing violent is happening. A camera light moves through black water and reveals a small patch of animal life or sea floor, while everything beyond it remains invisible. The visible world becomes a tunnel cut through darkness. The mind understands that the illuminated field is tiny compared with the volume around it. In that imbalance, unease grows. Writers and filmmakers often compare the deep ocean to outer space, but the two produce different forms of unease. Space feels distant and open. The deep sea feels close and crushing. Space is imagined through stars. The deep sea is imagined through the absence of them. The ocean is deeper than you think because it becomes psychologically deeper as the normal signals of human orientation disappear. Depth is also historical. Beneath the sea lie drowned coastlines, submerged river valleys, shipwrecks, whale falls, ash layers, climate records, and traces of ancient life. During glacial periods, sea levels were lower and the outlines of continents were different. What is now seabed in some places was once exposed land or coastal habitat. As ice melted and seas rose, landscapes disappeared beneath water. Sediments on the seafloor preserve clues about these changes. Tiny shells record past ocean temperatures. Chemical ratios speak of ice volume and circulation. Volcanic ash marks eruptions. Organic layers reveal productivity and oxygen conditions. The bottom of the ocean stores a chronicle of Earth's past that can only be read through patient scientific recovery. A core lifted from the seafloor is not just mud. It is a timeline. This buried past makes depth more than a measurement. It turns the ocean into memory. The deeper the water, the more completely that memory can be hidden from ordinary experience. Yet it remains there, below shipping routes and storms, beneath the tracks of whales and the shadows of clouds. The ocean is deeper than you think because history itself is layered into its floor. When people imagine the Earth, they often think in surfaces. Continents, islands, mountains, roads, cities, coastlines, and clouds form the visible world. The ocean challenges that habit. It asks us to imagine a planet whose greatest dimension is concealed under moving water. More than half of the planet's surface lies deeper than 3 kilometers below sea level. That is not a detail. It is a structural truth about Earth. A world with that much hidden depth cannot be understood only by what appears above it. Climate, biodiversity, geology, sound, chemistry, and even human infrastructure are tied to the vertical architecture of the sea. The deep ocean stores heat, traps carbon, hosts ecosystems without sunlight, records climate history, carries global communication cables, and shapes the circulation of the world. It is not a distant appendix to the planet. It is one of its main organs. The ocean is deeper than you think because Earth itself is deeper than we usually allow in our imagination. We live on the thin upper margin of a water planet. Beneath our weather and coastlines lies an enormous interior of pressure, darkness, time, and life. To understand that is to understand that the blue of Earth is not just color, it is depth. The ocean is deeper than you think because the surface is persuasive. It offers movement, reflection, color, and horizon. It invites the mind to stay horizontal. Yet beneath every wave lies a vertical world of pressure and darkness. Beneath the swimmer lies the diver's limit. Beneath the diver lies the submersible's realm. Beneath that lies the abyss. Beneath the abyss lie trenches that reach toward the deepest edges of life. This depth matters. It shapes climate, stores carbon, holds biodiversity, hides geology, records history, and challenges engineering. It contains more living space than land. It connects the atmosphere to the seafloor and the surface to the deep past. The ocean's vertical scale is one of the central facts of Earth, though it is almost invisible from shore. To understand the ocean, we must stop seeing only the blue surface. The sea is a world with height turned downward. It is a mountain range inverted, a sky filled with water, a darkness layered with life. Its depth is not a number alone. It is the hidden architecture of the planet,